Earth, a unique planet, restless and dynamic. Continents shift and clash. Volcanoes erupt. Glaciers grow and recede. Titanic forces that are constantly at work, leaving a trail of geological mysteries behind. Among Earth's many geological wonders, there's nowhere more dangerous than Mount Vesuvius. It's a volcano well known for its violent past, as witnessed by the remains of its victims, frozen in time for nearly 2,000 years. But Vesuvius is still very much alive, and only now are its mysteries being revealed. A new discovery of a vast magma chamber of boiling hot rock beneath Vesuvius. Just one of many startling new clues to how the volcano could threaten one of Europe's most crowded cities with a fiery reign of death and destruction. Unlocking the secrets of Vesuvius exposes the awesome forces behind how the Earth was made. The next eruption at Vesuvius could kill more people than any other volcano in history. 3 million lives are at risk. On the west coast of Italy, towering 4,000 feet over the city of Naples, stands Mount Vesuvius.
The death toll would be big, running into the millions. And so it really is the catastrophic nightmare scenario that we all fear.
The challenge for geologists is to figure out what could trigger Vesuvius's next eruption and assess how such a potential horror would unfold. The first catastrophic explosion would burst from the ground here, from the depths of the volcano's 2,000-foot wide crater.
Within seconds, the whole thing would be ripped apart.
It's the nightmare scenario that everyone fears. A cloud of fiery volcanic debris would blast down the steep sides of the volcano at 450 miles per hour, twice as fast as a Formula One racing car. Anyone within 10 miles of the crater would be caught in the eruption's death zone. Nothing could stop this boiling cloud of ash and rock.
Now, you might think that the people living across the water there in Naples would be safe from the volcano, but we know that that wouldn't be the case. It moves across the sea, picking up speed as it goes, not walking, but literally running towards Naples. Imagine the panic in downtown Naples as this hot, dark cloud of volcanic ash and dust descends on the city.
There's nowhere to hide. Men, women, and children are incinerated.
And the temperature's 600, 700, 800 degrees Fahrenheit. I mean, that's enough literally to boil the blood in your body.
Other victims suffocate. Anyone trapped between downtown Naples and the volcano is dead. Volcanologists had always believed that the city of Naples itself was safe from Vesuvius. They thought that even the volcano's biggest eruptions couldn't reach further than the city limits. A belief that was shattered by new research deep beneath Angevin Castle in the heart of Naples.
Wow, this is an extraordinary deposit extending from this level all the way up to this point, which makes it about 4 feet thick.
The layer Sheridan has found is an accumulation of ash that rained down on the center of Naples from a massive eruption in the Bronze Age, around 1780 BC.
It traveled 10 miles from the volcano across the Bay of Naples to this point.
miles further than any other previously known eruption of Vesuvius. Astonished scientists could not ignore such convincing evidence.
Finding a deposit right in the center of Naples has changed the way people think about their safety from eruptions at Vesuvius. And people are now considering that Vesuvius may truly represent a risk to their safety.
If Vesuvius produced such a massive eruption once, it can again. There's a further monumental-sized piece of evidence that reveals the awesome scale of the blast in 1780 BC. These are the 3,700-foot-high cliffs named Somma. It's 4,000 years ago on Mount Vesuvius. A colossal eruption rips the volcano open. Molten rock blasts out of the cone, emptying out the underground reservoir that geologists call the magma chamber. This continues for hours until something literally earth-shattering happens. When the magma chamber empties past a critical point, the entire mountain collapses in on itself to fill the void below. The 1780 BC eruption was so massive that it brought down a mountain and emptied 63 billion cubic feet of pulverized rock onto the surrounding countryside. That's enough to cover the whole of Manhattan Island to a depth of 100 feet, or bury the state of Florida in almost half an inch of ash. This mega eruption is now the blueprint for Naples' worst-case scenario. It's one of the factors making Vesuvius the most dangerous volcano in the world. And it's why scientists are racing to prepare for the next disaster. To investigate what deadly forces could be unleashed on the city of Naples, scientists must understand the eruptions of its past. And no explosion is better studied than the one that destroyed Pompeii, the Roman city that lay 7 miles southeast of Vesuvius. In the year 79 AD, an eruption killed 25,000 people, 1/4 of the population, and left the area uninhabitable for 300 years.
Behind me here is the very material which buried Pompeii.
The volcanic debris is made up of ash and an unusual white rock.
Really, first impressions are that it's really rather light. And if I get in a nice close look there, the rock itself is absolutely riddled with holes.
The holes were bubbles of trapped volcanic gas.
Now, this light white rock is called pumice. Now, pumice is magma that's filled with bubbles so much that it'll actually be able to float. And pumice is the only rock in the world that can float.
The trapped bubbles show exactly how the pumice was formed.
The magma beneath the volcano is a bit like the cola in a sealed bottle like I have here. We have liquid and dissolved gas.
If the pressure is released suddenly, the dissolved gas explodes out in the form of bubbles.
The bubbles in the cola have turned it into a froth, and this frothy mass that's coming out of the cola is just like in a magma chamber. When the gas escapes from the magma, forms a magma froth which violently comes out the volcanic vent.
So the discovery of pumice proves that the volcano created magma foam. And that can only mean one thing. The eruption must have involved a major explosion.
The explosion sent the magmatic foam and ash over 17 miles into the atmosphere. This is twice the height of your average cruising aircraft.
Amazingly, there is a surviving eyewitness account of the disaster written 2,000 years ago. Every detail of the eruption was noted by the 17-year-old Pliny the Younger, who was, in effect, one of the world's first volcanologists.
Pliny, a naturalist, produced the first scientific recording of a complete volcanic sequence. He writes, "A cloud was forming. Its appearance and shape would best be expressed as being that of an umbrella pine, similar to this large tree I have behind me, since, stretched upward like an extremely tall trunk, it then spread out like branches."
So the cloud spread out at the top, forming a mushroom shape, which is still known as a Plinian column. For Pompeii, this cloud was lethal. The pumice and ash was carried by the prevailing wind to fall like a deadly gray snow on the ancient city.
And it was this volcanic fallout that started to thicken the air. The people who were initially amazed by the volcanic eruption now started to find it difficult to breathe.
Many of the victims of Pompeii suffocated on the fine ash.
We see a picture of people struggling to breathe, like this body here, which is curled up with their hands close to their face, essentially recording the last final breaths of the people as they filled up with ash and hot, fiery dust from the volcano.
Such a rain of ash falling onto the crowded streets of Naples today would cause millions of casualties. In trying to solve the mystery of what makes Vesuvius the most dangerous volcano in the world, scientists have uncovered two crucial pieces of evidence. The pumice from Pompeii proves that Vesuvius can produce explosive eruptions, the most devastating type of volcanic blast. A thick layer of volcanic ash found underneath Naples shows that Vesuvius has the power to stretch out and destroy the city. A similar-sized blast today could kill 3 million people, which would be the world's highest volcanic death toll. Geologists know that some victims would die of suffocation, but the discovery of charred human bones are clues to another, more terrifying death wrought by Vesuvius. Geologists are investigating the deadly threat of Mount Vesuvius. Remains at the Roman settlement of Pompeii show how thousands died, buried by a choking rain of ash and rock. But in 1981, excavations 4 miles to the west of Vesuvius showed that an even more horrific fate awaited the people of this Roman town, Herculaneum. When the volcano erupted in the year 79 AD, Herculaneum was a busy resort town of 10,000 people. But surprisingly, when the ruins were first excavated, a mere 15 bodies were found.
And many people thought that that was because they could see the eruption early on and were able to escape. But when they dug down further, here to the shoreline and to these boathouses, this is where they found the truth.
The boathouses hid a grisly secret. These are the remains of the Romans caught trying to flee the volcano. The skeletons still lie exactly where they fell 2,000 years ago.
It's hard to imagine what it must have been like. Over 300 men, women and children here at the water's edge in Herculaneum. Here the boathouses providing shelter from the falling volcanic debris. And it was these boathouses that were going to become the final resting place of their tomb in Herculaneum.
For geologist Dr. Jerem, these remains hold the primary clue to exactly what happened during the eruption 2,000 years ago. The mass grave is treated like a crime scene. Photographic evidence is taken back to the laboratory for further investigation. The positions of the bodies themselves are the first clue to how quickly a volcano can kill.
Here we have a body that sat up against the boathouse wall in Herculaneum, and in the arms of this adult is a child. And they're sat there almost as though they were relaxing or resting against the wall. It's almost as though you could be sat there chatting with this person and then they've been killed.
There are further clues to be found in the fine detail of the victim's bones.
At the end of many of the bones, you see this blackened coloration. And this can be seen on many of the examples in Herculaneum. And it really seems to occur at the points, like here at a sort of elbow joint, the points on the body where there's very little flesh and the bone is very, very close to the surface.
For years, scientists debated what the discoloration could mean. Until in 1991, researchers from the University of Naples came up with a simple solution.
I'm going to recreate the one experiment that unlocked what happened at Herculaneum.
Dr. Jerem is burning several pig bones at increasingly superheated temperatures.
I'm going to rack up the temperatures, start to try and burn the flesh on the bones, and then hopefully get to the point where I can start to produce blackening of the bones and reproduce the colours that we see in the Herculaneum bone deposits.
Dr. Jerem burns one bone at 500 degrees and another at 700 degrees Fahrenheit.
The flesh is all starting to burn now, but clearly we're not really burning the bone here.
It is not until Dr. Jerem raises the temperature to 900 degrees that the bone itself is burnt.
Well, it finally looks like we've got somewhere where we're starting to burn the bone.
Scraping away the charred meat and skin reveals the bone underneath.
Here on this picture from Herculaneum, you can see on the end of this bone these brown into black transitions with some nice white bone behind. You know, this is exactly what we're seeing in the 900-degree experiment. So we can produce the blackened bone features that we see at Herculaneum with high temperatures, burning the bone that's exposed, but the bone that's covered by a bit of flesh gets protected and stays white. And this could be the only way in which we get these blackened bone features at Herculaneum.
The blackened bones show that on the day of the eruption, the air temperature 4 miles from the volcano reached 900 degrees Fahrenheit. That's hotter than the blast from an aircraft's jet engine. For years, scientists puzzled over how Vesuvius could have raised temperatures so high, miles from the volcano. But then, a totally different type of clue suggested the answer. At the small town of Boscoreale, just 1 mile southeast of Vesuvius.
This strange pillar-like structure, I mean, at first impression it looks like some very strange, weird concrete post, but it's far more fascinating than that. And the clues are really in the base. We see a number of smaller structures radiating from the base. And these are actually roots. You see them feeding back into this big stump-like feature. This is a fossilized tree.
The tree was buried in volcanic material. As the original wood rotted away, it was replaced by rock and ash, which mixed with water and set like concrete.
Almost like a jello mold of a tree upstanding that was upstanding over 2,000 years ago.
The shape of the tree is deeply significant.
And as we work up this fossilized tree, it suddenly veers and bends at this point here. Now, if we can imagine, about 2,000 years ago, this tree was alive. And suddenly it's been wrenched over and bent towards that way, and it's also been fossilized in that position. Now, when we look at the local geography, we know that Vesuvius is over that way. So some force which is bending this tree and fossilizing it must have been coming from that region.
The clues of superheated temperatures miles from the volcano and a force that bent a tree almost double suggest only one thing. They're evidence that Vesuvius produced another deadly weapon. A pyroclastic flow.
Pyroclastic flows are a dynamic mixture of hot rock, ash and gases that move fast and violently down the side of a volcanic mountain.
These deadly boiling clouds reach speeds of up to 450 miles per hour, faster than a bullet train, and temperatures of up to 2,000 degrees Fahrenheit, hot enough to melt gold.
At the early stages of the eruption here at Herculaneum, you would have seen a big eruptive cloud coming out of Vesuvius and heading off up into the atmosphere. But just imagine how scared you would have been watching this cloud suddenly turn round and the black cloud starts heading towards Herculaneum. This cloud of hot material, hot, boiling, bubbling pyroclastic material starts to enter the city streets, starts enveloping you and heading off down towards the port. And that was it. The pyroclastic flows had hit Herculaneum.
Just hours later, the town was buried completely. Striving to understand how deadly Vesuvius can be, investigators have found vital clues to the devastation from the searing heat of pyroclastic flows of the past. Horrific burns on human bones prove temperatures got to a blazing 900 degrees Fahrenheit, 4 miles from the volcano. And a 2,000-year-old fossilized tree reveals the power of the speeding flow of hot rock, gas, and ash down the mountainside. But pyroclastic flows are not the only deadly force in Vesuvius's arsenal. It has an ultimate weapon: rivers of molten rock that pour down the mountainside to burn and bury, all in its path. Vesuvius has yet another deadly weapon in its arsenal, one that was captured on film during its most recent eruption on March 18th, 1944.
Cameras record the spectacle of Mount Vesuvius.
A 5-mile-high cloud of ash climbed into the sky over Vesuvius. Pyroclastic flows rushed down its slopes. But worse was to come. Floods of molten rock overflowed from the lip of the crater to swallow up entire Italian villages. 34 died, and thousands were left homeless. These rivers of magma on the surface of the Earth are called lava flows.
One of the most prominent features in Vesuvius landscape today is this river of molten lava, solidified lava, on the sides of Vesuvius.
There are significant deposits of the 1944 lava flow extending 12 miles down the side of the cone.
And looking at it closely, I can see that there are no bubbles.
Unlike the lightweight pumice that rained on Pompeii, this solidified lava is dense and hard.
And actually that is the clue that is telling me that this was not an explosive eruption. This wasn't hurled into the air. Instead, the gases seeped through the lava before they came to the surface.
Only a very free-flowing and liquid lava could have let the gases escape underground in this way. And with very little explosive gas left inside the lava, it flowed out rather than burst out of the volcano.
Lavas will flow down the slope using the easiest way, and this is going to be very much the same path as water will take.
Floods of lava at more than 2,000 degrees Fahrenheit poured down the slopes. Lava flows are the hottest natural material on the face of the Earth, Vesuvius's ultimate weapon, an unstoppable force destroying all in their path.
The word lava, it actually comes from the Italian, and it was coined in here. It comes from lavare, which is to wash. And it is basically explaining how lava flows, once they move over a city, they wash out everything. Nothing is left.
Since 1944, Vesuvius has been quiet. A calm has settled on the people living in its shadow, and today Vesuvius is even a popular tourist attraction. But teams of scientists still go into the crater searching for any signs that the volcano may be awakening.
Okay, let's go.
It's a 1,000-foot drop to the crater floor.
Let's go down slowly. There are a lot of rock falling today.
The volcano is crumbling in on itself. The walls made up of loose rock thrown out in the 1944 eruption are slowly collapsing back into the crater. Even before he reaches the bottom, Orsi can see and smell gas and feel the heat of volcanic activity.
Yeah, the smoke you see around here, it's gas coming through fumaroles.
A fumarole is a crack in the Earth's crust which emits steam and gas from deep underground.
And it's an indication, one of the indications that the volcano is still active.
A live volcano positioned next to a city of 3 million needs to be under constant surveillance. So much so that it is now the most closely monitored volcano on Earth.
Composition of the gas and temperature, it's related to the state of the volcano.
These gases are the volcano's early warning system. Any significant change in their temperature or composition would set the scientists' alarm bells ringing. Today's examination shows no change. So, for the moment, Naples is safe. But this lack of activity is not necessarily a reassuring sign.
So I think there is a pattern on how Vesuvius behave in terms of you seem to have a period of quietness, and then you have a very large eruption, and then you tend to have a period of quietness, and then another large eruption.
So the danger is, the longer the volcano stays quiet, the more magma is allowed to accumulate. So when it does finally erupt, the bigger the blast will be. New clues at Vesuvius have concerned the volcanologists who were investigating its deadly power. Dense, solidified rock is evidence that Vesuvius possesses the ultimate weapon: high-temperature lava flows capable of destroying all in their path. Hot fumaroles in the crater prove the volcano is still active. But new scientific techniques reveal a vast magma bomb hidden miles underneath the volcano. A bomb that is primed and could blow at any time. Scientists have uncovered clues suggesting that the awesome power of Mount Vesuvius could soon be unleashed in a massive and devastating explosion.
For an eruption to happen, volcanoes need two things. They need a source of magma, which is a magma chamber close to the surface, and they also need a trigger. It's a bit like a bomb and a fuse. So once you have these two things in place, it could blow at any time.
The key evidence is bubbling up through the ground just 10 miles west of the volcano.
So my overriding sense of this area is one of intense heat. When all around me it's not just the sun that's hot and baking down, and there's steaming gas coming out of the ground and cracks and fissures. It's if the whole ground is kind of alive with thermal activity. And it just tells me, screaming out loud, that there's heat just percolating up from the ground towards me.
The steam gets to temperatures as high as 300 degrees Fahrenheit.
And the steam is also coming up with a gas called sulfur dioxide, and I can smell it really strong. In fact, it's almost choking when you get the wind blowing it into your face. So the telltale sign of this activity The sulfur dioxide activity is the coating of yellow material, yellow sulfur crystals, on all the rocks around me. There's only one thing on Earth that can drive this kind of activity: the sulfur, the hot geothermal springs, and the hot gas, and that's magma at quite shallow levels.
For years, scientists have known that a chamber of molten rock lies under Vesuvius, but nobody could see it. Then, in 2001, geologists used a pioneering new technology to investigate the ground under and around the mountain. It's similar to the way a doctor uses ultrasound equipment to reveal the shape and size of a human baby in the womb. At Vesuvius, volcanologists used sound waves, billions of times more powerful, to take a picture under the earth. They detonated small explosions at different locations around the volcano, radiating waves out under the ground. Measuring the speed of the waves reveals whether the rock through which they're traveling is solid or more liquid, hotter or colder than the surrounding ground. Computers mapping the wave movements from the surface print out a ghostly but terrifying shape.
For the first time, seeing that sort of information is very exciting for geologists.
The magma chamber is so wide, it stretches well beyond the 1-mile base of the cone itself.
It's 250 square miles, or about half the size of New York City, so that's quite an impressive feature.
It's not only impressive, it's also potentially deadly. The vast reservoir of molten magma could fuel Vesuvius's greatest eruption. But still, no one knows for sure what might set off this seemingly inactive magma.
Well, there's some really exciting evidence that's been found that suggests that Vesuvius might have a bit of an unusual trigger.
In searching for the secret trigger mechanism of Vesuvius, Dr. Petford examines the pattern of when past eruptions have occurred.
What this line here represents is a timeline from 1600, where I'm stood, up to pretty much now.
Each stick represents an eruption of Vesuvius during the last 400 years.
And the first one is here at about 1631. And then there have been 3 more significant volcanic eruptions.
As the timeline takes shape, Dr. Petford inputs more data. This time, the dates of another seemingly unrelated set of natural disasters.
We've got records of earthquake activity as well. So I'm going to use these stones here to represent earthquakes. And these would be earthquakes that took place within about 100 miles of the volcano.
As Dr. Petford positions the major earthquakes of the last 400 years, a pattern emerges between the tremors and activity at Vesuvius. It has been possible to investigate this supposed link only because there are such uniquely detailed records about the volcano. Vesuvius has been inhabited for so long that every one of its eruptions of the past 1,000 years has been meticulously documented. Also, the volcano sits in an earthquake hotspot. This region experiences more tremors than anywhere else in Europe, activity that has generated further detailed records for geologists to study. When all this information was analyzed together, a statistically proven link was found. The evidence for this relationship is convincing at Vesuvius. But the idea that earthquakes can cause eruptions is still hotly debated worldwide.
The idea that earthquakes and volcanoes are related is not a new idea. In fact, it was Charles Darwin on his journeys to South America in the 1800s who first proposed that there could be a link between an earthquake and a volcano he saw erupt a few days afterwards.
Darwin was in Chile in 1835 when an earthquake struck. Days later, he witnessed the eruption of a chain of volcanoes. To him, the relationship was clear that one was the cause of the other.
And really since then, over the last couple of hundred years, geologists have debated back and forward how real, if you like, this cause and effect relationship is between earthquakes and volcanoes.
Despite continuing controversy, many scientists do believe that the next huge eruption from Vesuvius may be triggered by an earthquake. The theory suggests that pressure waves rippling through the Earth's crust can squeeze the magma chamber.
If you imagine that this bottle represents a magma chamber down beneath a volcano, and that the water inside the bottle here is lava or magma, then as the earthquake pressure wave moves towards the magma chamber, it interacts with the walls and starts to squash the chamber. Chamber walls sort of pinch together like this, and it drives the magma up to the surface.
But even then, the eruption may be delayed. Historical records suggest the volcano may not stir for months or even years after an earthquake has passed.
There could be some good reasons for that. I mean, one might be that the earthquake builds up pressure slowly inside the volcano.
So the effect of the pressure waves are not immediate.
Or that you need more than one earthquake. You might need multiple earthquakes that progressively increase the pressure inside the volcano.
Each wave squashing the chamber a little more each time.
Until the last earthquake that comes along is effectively, the straw that breaks the camel's back, and it's that earthquake that pushes the system into critical instability and makes an eruption.
After thousands of years of study, scientists still do not fully understand what causes an eruption.
So an important thing about Vesuvius is that if we can make sense of this data set that we've got for this volcano, if we can come up with a new model for earthquake-related volcanic eruptions, Vesuvius could be the world leader in helping us to understand how other volcanoes on the planet might work in a similar way.
If earthquakes are the trigger for Vesuvius, then it is possible that the next eruption may already have started. Two massive earthquakes recently sent shockwaves racing through the ground near the volcano. In 2002, the first quake struck just 40 miles northeast of Vesuvius. This was a magnitude 5.4 tremor. 30 people died and thousands were evacuated from their homes. Even more recently, in 2009, a magnitude 6.3 earthquake killed more than 300 people in the town of L'Aquila, 60 miles north of the volcano. This was the worst such disaster in Italy for 30 years. The concern is that the shock waves from these quakes may already have shaken Vesuvius's monstrous magma chamber and triggered the start of a new eruption. The clues are adding up in the race to predict when Vesuvius will erupt. Scientists have gathered two startling pieces of evidence. A huge magma bomb beneath Vesuvius proves the volcano is primed with the fuel for a massive explosion. The historical pattern of earthquakes and eruptions suggests the trigger may already have been pulled. Each new piece of information takes scientists one step forward in their quest to foretell when Vesuvius may blow. But even predicting the eruption may not be enough to save the lives of the 3 million citizens of Naples. Recent discoveries around Vesuvius reveal that if a blast like the one in 1780 BC occurred today, it would reach the heart of Naples, a metropolitan area with 3 million people.
Vesuvius is an active volcano and is also explosive, so it's quite dangerous. In addition to that, there is a very large population living around Vesuvius, so also the risk is very high.
Studies of the surrounding landscape suggest that the volcano's most lethal force, the pyroclastic flow, would not only reach Naples, but would be concentrated down in the direction of the city. The high cliffs of Somma partly surround the cone of Vesuvius. If there was an eruption, these walls would act like a funnel, channeling the majority of the boiling volcanic debris to the west, straight towards the city. Vesuvius is like a loaded gun pointed right at Naples.
The new evidence that we have is really important. It points to one very critical point, that Naples is not safe. This area could be hit, it could be targeted.
This new information, in addition to the discovery of volcanic deposits in the heart of Naples, has spurred the city to review its 2001 evacuation plan.
The evacuation plan currently only deals with those people who live on the slopes of Vesuvius in the villages and towns around. That's about 600,000 people. The city of Naples, here where I am now, isn't presently included in the evacuation plan, and of course that's where the majority of people live.
Geologists are key to putting new evacuation plans in place. But planning is the easy part. Knowing when to put those plans into action is the most difficult call to make.
The decision of evacuating or not and when to evacuate is probably the $1 million question.
If scientists seem to exaggerate a threat and recommend an evacuation, the next time people might not pay attention.
If they're evacuated too late, the price might be thousands of people dead.
It's a dilemma faced by volcanologists around the world. Mount Vesuvius is only one of 3,000 active volcanoes. 9% of the world's population, some 450 million people, live in areas threatened by a volcanic blast. Mount Rainier stands 54 miles from the 500,000 residents of Seattle. Popocatépetl is located 44 miles from 9 million people in Mexico City. And Mount Fuji stands 60 miles from the 12 million citizens of Tokyo. On average, 3 volcanoes a year erupt, causing deaths and injuries. The hope is that lessons learned from Vesuvius will one day help protect people around the globe. Mount Vesuvius still has many secrets to tell. But so far, geologists have put together a disturbing portrait of what many call the world's most dangerous volcano. Pumice from the ruins of Pompeii, evidence of the explosive power of Vesuvius. Charred human bones demonstrate the 900-degree temperatures of the mountain's pyroclastic flows. Ancient layers of ash in downtown Naples prove that Vesuvius has the power to engulf the city. And new seismic investigations reveal a 250-square-mile magma chamber sitting under the volcano. It's a ticking time bomb. Geologists who study how the Earth was made believe that it's a geological certainty that Naples will one day feel the wrath of the volcano. Even now, Vesuvius is armed and waiting for its next eruption. Dynamic proof that the Earth is never at rest.